Morning, everyone. My name is Tim Egan. I'm also joined with Zach Smith. He'll be speaking during the demo part. We'll be
Hi there.
presenting on, hey, there he is, Apatos Reshoring. We actually kind of changed our name throughout the process, but we'll get into it. So I'm not going to read all of this, but we kind of had to map out the problem, and it's kind of more of a workflow problem that we found. But vertical construction projects, once out of the ground, all rely on shoring and reshoring to ensure safe work environments on the job site as you work up the buildings. Heavy duty shoring equipment is used to keep the structural elements stable to prevent collapse during building construction, renovation, expansion projects. One of our team members, who we'll get into, Jason, has 4 years of concrete formwork design and experience of analyzing these large structures for concrete reinforcing for the formwork, and identified a need within the market to build a tool to assist in the analysis of the placement of these reshoring items, as well as kind of unpack some of the 3D data that you have as a result in static loads on each slab. Historically, these calculations are performed within Excel workbooks, not really tied to the engineering models, take weeks to produce, and produce results that are potentially areas of opportunity to enhance on project schedules by opening up other work areas and just kind of unpacking some of this data. Where our name comes from is Apatosaurus, is a genus of herbivore dinosaurs, actually. And we came upon this by augmented placement and analysis tool for optimal structural reshoring. Kind of worked out. And now I'll leave this to Zach to kind of let this run. So I'll see if this works. So.
Yeah, we'll see. I'm Zach Smith with the Static Not Start team. Today I'll be presenting the Apatos Reshoring toolset. This is intended to support construction detailing, design, and engineering workflows. Our first command is create visualization view. This will give the model some color. It will generate a bunch of generic models tracing the geometry of the structural framing, the floors, the structural columns, and the walls in the structural model, and projecting capacities and loads throughout the building. This is intended to be a support tool to help communicate between those different members of a structural design team and understand where loads are balanced in the building. Our next command is place temporary shoring. This is based off the simple method for reshoring. We are combining the load of the level above, the capacity of the level that we're currently on, the capacity of the reshores that we're selecting, and the load of other structural members like structural framing and walls and columns. Using those numbers, we will distribute the reshoring members throughout the building. The further down you go, the wider the spacing is. And at a certain point, the load no longer needs to be redistributed. It has balanced out once we pass this level. So now that those have been placed, we can generate some deliverables. Create reshoring layout sheets will generate full floor plate sheets. They will contain the reshoring members that we've placed programmatically. They will dimension from center to center of those reshoring members. They will include two schedules, one of the level, which will indicate the loads on that level, and another of the columns, and another of the reshore columns. Where those reshore columns will indicate the number of columns that are on that level, the pours that they're in, the kind of reshore that we're using, the clear shore height, and minimum and maximum heights. And lastly, we'll create pour sheets. This one does take a little bit longer to run just because it generates quite a few more views. But the principle is the same as the reshoring layout sheets. These are just broken into smaller chunks by pour. We represent those pours with scope boxes in the model. So in this one, we'll have 6 different pours projected through 24 levels. of the building. On these sheets, we will include the same things that we did on the reshoring layouts. We'll have dimensions between center to center of each shoring column. We'll have a schedule for the load applied to the level, and we'll have another schedule for the shores in that pour. All right, now we have our sheets. Oh, this is a low level that doesn't have any reshores on it. And here we are. There are reshores, dimensions from center to center, the loads applied to our level, and the reshores on this level. Thank you very much. Feel free to reach out if you have any questions about how we did it.
All right, so I'm going to run through kind of some of the background of what it took us to get to that product. A lot of the process was really just digitizing the current process, more or less. We basically had to identify that sometimes, contractors don't even use the 3D models that are available, and that's definitely the case here. In Jason's experience, everything really was starting with 2D drawings, where he was tracing everything. And getting through everything through, just the geometry to a spreadsheet. He would first do that for the slabs of the geometry of just the slabs, and then go move into all the structural elements, transpose that into an Excel sheet, and then calculate both the construction live load, which is just all the weight of the reinforcement, the formwork, the workers, the equipment, and then as that translates throughout the building, as you move up it, you kind of have to work through it. The engineering methodology that we used was using the simplified method, which I'm not going to go into all this because we only have a few more minutes, but there definitely is some listed assumptions here that we definitely are leaning on very heavily. So from an engineering perspective, this does stand true as far as like most buildings. There is definitely some caveats to this. So not within our MVP is a whole bunch of these other caveats that definitely can affect a lot of these calculations from being straightforward. And that's where this is really a tool to help automate some of the tedious process of the greater areas. You saw Jason really threw a curveball and put us some really out there ledges. The tool isn't really built for it just yet, but that's where we'll eventually like to bring it. The product selection workflow, this is a map that we kind of use My Maps to kind of process out what we were going to work on and how much we were going to spend on what. From here, you can basically see that there's a lot of moving pieces, and there's a lot of manufacturers that have different ratings for different, different polls. So you kind of have to know what your catalog of items is going to be. So we actually built out some Revit families that are dynamic to the clear shore height between the different heights between slabs, and based on those you have, based on the extension, you have different loading capacities. So we built those all out dynamically, so then they actually extrapolate to the right placement using all of the math that Zach was able to pull through the tracing objects. And that is the existing workflow, and that's what we kind of digitized through this process. This is our MVP product map of what we had to kind of understand to really get to where we wanted to build our final deliverables, which are actual drawings. I'm not going to sit on this for too long because I want to go through the features. So it automates the structural analysis and placement, reshoring on the simple method. It generates color-coded visualization sheets indicating demands and capacities. We had that working in testing. We don't have it in the trial right now. That not only just that colored picture that you can actually see as a background right here, we actually had all the sections viewed, so you could actually see like in the field by color as well. It automates the layouts by level, so you can get them submitted for the structural engineer, and also automates those pour sheets, so you can kind of go out into the field and know exactly where your reshores are going. Those clear visuals really unpack some of the data that's typically hidden. Absolutely is time savings. We ran through that. We did clip a little bit out of the video, but we're talking minutes versus weeks that this would normally take to get most of it done. The data entry, there's still some hard coding that we have right now. We try to build a front end to collect some of the structural size of the building. We just really couldn't get that built. You also do get a model-based takeoff, so you saw those schedules. Once you start trusting those, then you can really lean on them. We built this with a Revit API, .NET Framework, C#, XAML. We connected it to Assemble, so that's what you see in the background there, just to kind of see what it looks like visually. And we also use the template from Assemble to build a Power BI, just a proof of concept that we could track the installation of these and kind of just share that as a tool. So this is what those deliverables look like. So left-hand side is the one section drawing of the final pour, and then you also see that we have the Assemble model colored by those pours, so you can actually understand how many pulls you have per floor as it goes up.
30-second warning. 30-second warning.
This is our Power BI proof of concept, just to show that you now can kind of actually see that same data that to kind of forecast out by floor. And then this is the unsuccessful tech that we tried. We tried to take 2D PDF markups, pull it in through XML, but we only could get X and Y in length and width, so we couldn't get all of the crazy shapes that we found. So we threw that away. We also tried to build a front end to collect the structure of the buildings. We didn't have enough time to build all of the data storage we needed. The next steps, we're going to try to bring it into Forge, potentially, design automation API for adding more reshores, UIs for selecting reshores and building interface, like I mentioned, automating the parameter insertion, earn value tracking, anything else you could use the model for. And then, yeah, multi-year support. And that leaves us, yeah, with the group. So we all kind of threw in a whole bunch of different experience, and yeah, happy to be here. Thanks, guys.